Hey guys, in this video we'll be discussing the Codeforces education round 150 that was rated for Dev 2. So we'll be discussing the first four problems, that is game with board, keep it beautiful, random numbers and pair of segments. So let's get started with the very first problem. The very first problem is game with board. So what it states is that Alice and Bob are playing a game. As always, Alice goes first, right? And in this game there are n numbers that are written on the board. Now what you'll do is that if the player has to choose two or more numbers if it's available, right? So two or more numbers that should be same. For example, if this is the sequence that's written on the board, then over here 1 is same, 2 is same. So there has to be two or more numbers that are actually same, right? And then she or he is gonna combine it so as to produce its sum. So what you can do is, if this is the sequence that is given to you, you'll say, okay, I'm gonna collect these two, and this would sum up to 2, right? And this would be a resulting sequence. Or you could have said that if I'm gonna choose two numbers that are 2 over here, right? And the sum you are gonna get is 4. So then this would have been the sequence. Or you could have selected all these 2's and the sum you're gonna get is 6, right? Now the claim over here is that if my n, right, I hope you understood the problem and we have already gone through the same. So if my n is greater than 5, right, in that case Alice would always win. Alice wins. Now why is that the case? So let's just analyze what happens if n is equal to 2, because n is at least 2, right? That's already given. If n is 2 or n is 3, n is 4, then what happens? Okay, it was a greater than equal to, okay, n, never mind. Okay, if n is 2, then Alice has a 1, 1, right? So Alice can combine it, so it will be 2. She'll pass 2 to Bob, and now Bob cannot make a move. And as per the rule of the game, the player who's not able to make a move actually wins, right? So now Bob wins. If n is equal to 3, then Alice can either make it like a single 3, right? Or Alice can make it 2, 1, right? That's the only two ways she can actually combine it. In both these scenarios, Bob cannot make a move and again he wins. What if n is equal to 4? If n is equal to 4, she can either make 3, 1, right? Or she can make 2, 2, right? Now, not 2, 2, but 2, 1, 1, right? Now in either case, in either of these cases, if she's going to pass this value to Bob, then what would happen? In this particular case, Bob would say that I have the choice, right? I can combine a 2, 2 and I can pass it back to you, right? If that happens, then Alice would be getting a 2, 2 itself, right? So she's also able to make a move and she'll convert it to 4 and give back to Bob, and now Bob would not be able to make a move and hence Bob would win again. So whenever n is less than 5, Bob is always winning. Now let's say what happens when n is equal to 5. If n is equal to 5, what Alice can do is she'll say that, okay, these 3 and these 2 are something I have, right? So I'll sum up these. So the sequence I'm going to pass to Bob is 3, 1, 1. Now Bob would, it's going to be a compulsion on Bob to choose these two because he has to perform a move if it's possible. So this is the sequence that he's going to give back to Alice. As soon as he gives this sequence back to Alice, this is a valid sequence, or you can say that no operation can be performed on this, and hence Alice wins. Now what if n is something greater? Then also Alice is going to do the same. So she's going to select n minus 2 ones. She's going to create she's going to sum it up, and then she's going to pass the sequence to Bob. So the sequence Bob would get is summation of n minus 2, right? And a 1 and a 1. Now Bob would be compelled, it's a compulsion on him to sum these two up. So he'll sum these two up to 2, right? And he's going to pass back this to Alice, that is n minus 2 summation and a 2, right? Now since n is greater than 5 or equal to 5, so n minus 2 is greater than equal to 3, right? So the value Alice is going to receive is x is greater than equal to 3 and a 2. Now since this is the value that Alice is receiving, hence she'll say that I'm not able to perform a move, and hence she wins, right? So basically whenever n is greater than equal to 5, then Alice wins. Alice wins, else Bob wins. Cool. Okay, let me just show you the code as well. Okay, so if n is less than 5, then Bob wins. If it's greater than equal to 5, then Alice wins. Let's move to the next problem. The next problem is keep it beautiful. This was not a hard problem, but the implementation might seem a bit hard. So what the problem states is that a array is beautiful if you can pick some number of elements. Now it's not necessary. It's not always necessary to pick the number of elements, but if it's possible for you to pick some number of elements from the very beginning and append it to the very last. And then the resultant array should be sorted in non-descending order, right? So now they're saying that initially you have a blank array. Now they'll keep giving you some integers which you have to append to the array. So you're going to append to the last of it. And you're only going to append if the resultant array you're forming is actually sorted. So if it's sorted, you have to print a 1, else you have to print a 0, right? I hope this actually makes sense and you have already gone through the problem, right? So I'll just explain it via code itself, because explaining such questions are actually easier via code. So, okay. So here what I'm doing is that initially whatever integer I'll be getting, since my array is initially blank, so I can always insert it, right? So irrespective of whatever value it is, I'm going to insert it. Then I'm saying that what was the previous value. So I've already inserted the 0th element. So I'm going to store that value in pref, right? Now I'm going to traverse through all the remaining n-1 values. So I'm going to traverse over here. Now I'm saying is carried is equal to -1. Now what is carried equal to -1? You can take it as a flag itself, wherein I'm saying that this particular operation that they've specified over here, if I have performed it, then the value of carried would not be -1, else it would be -1 itself, right? So if my carried is -1 or my v0, right? So if I have not performed this operation either, right? Either I have not performed this operation or my v0 is greater than or equal to vi. Now what's this? Let's talk about it later. Let's understand the remaining things first. This would make sense. So initially carried is equal to -1. So this actually becomes true and we'll proceed ahead. So now we check that the previous value should be less than or equal to the current value. Then obviously we can add it, right? Then we'll add it. We'll update the previous, we'll print a 1 and then we'll continue, right? Else what would happen? Now there's another variable I have taken done, and the only reason I have taken so many variables is because I was actually initially testing it differently. But you can have simply said that if carried is not equal to -1, even this would work perfectly fine. Okay, let's just test it. Yeah, this is also working perfectly fine. Okay, so if carried is not equal to -1, so that basically means I've already performed that kind of operation that was mentioned over here, right? This operation. So I cannot perform this operation twice, right? In that case, I cannot append this element, hence I'll print a 0 and I'll continue. Else what I'll check is, now there should be some condition that needs to be satisfied, right? Because what's going to happen is that, let's say this is the array I'm already having. Okay, let's say this particular array, right? Now over here, I can pull this part up 3779. I can append this part at the very end. So it will become 2, 3, then 3779, right? Now the condition over here is that the 0th element, right? That the 0th element is actually greater than or equal to the last element itself, right? So that's what I'm checking over here. That the 0th element should be greater than or equal to the current element. Only then I can say that this particular operation would be possible. If that's the case, right? And I've already not already operated, or I have not already consumed that particular operation. In that case, I'll update. So done is not required. Let's remove that. Okay. In that case, I'll say that, okay, I can do this particular operation. I'll update my previous, right? And then I'm gonna update my carried. So you can actually make carried any value. So let's just make it 1. Either way, it's gonna work. Okay. Yeah. So this is the operation, right? And else, so else case would be that, okay, your carried was not equal to -1. So you have not performed that operation, but even the current element does not qualify such that if it's added to the array won't remain beautiful, right? So even if that's the case, then you're gonna print a 0, right? And then you're gonna continue. Now let's come to this particular point. Now what does this mean? That your 0 is greater than or equal to I. So this basically means that if you have already performed this particular operation, right? If you have already performed this particular operation, that basically means that the first part of the array needs to be added at the very end, right? Now, if you want to add the first part of the array to the very end, then whatever number you're going to add. So let's say I wanted to add another number over here. That was 4. So as soon as I add a 4 over here, then what would happen is that this cannot be, this cannot go over here because 4 would be greater than 3, right? So you can only add a number over here that is less than or equal to 3. So that's what I'm checking over here. So if carried is not equal to -1, that means the operation has already been performed. In that case, the 0th element needs to be greater than or equal to whatever element I'm adding over here, so that the beautiful operation or this particular operation that we can perform is actually able to help us to make the array beautiful. Cool. So that's it for this problem. I hope this was understandable. Let's move to the next problem. That is the problem C, random numbers. I'm not sure why this gave this problem. This looked like more of an implementation problem, or it didn't look like a standard C problem that is hard to understand, or in order to apply your brains. So what they're saying is that random numbers are denoted by capital Latin letters, that is from A to E, right? Now each of these letters have actually a value, that is A is 1, B is 10, C is 100, D is 1000, and E is 1000, right? Now you're gonna have this value over here. So for example, they have actually said that, okay, if this is the string that is given to you, then this is the value. Now the way they calculate it is that we start from the left, right? Oh, sorry, we start from the very right. We see a value. If we have already seen a value that is greater than it, in that case the value gets negative. For example, over here we have not seen any value that is greater than A, so it will be a plus. Now we go to C, we have not seen a value that is greater than C, it also would be a plus. Now we'll say we have not seen a value greater than D, so it also would be a plus. But as soon as we reach a B, so we have already seen D and C that were actually greater than B, right? So its value is actually a minus 10. Cool. So basically this is what we are doing. Now how would we solve it? So what they're saying is that you can at most make a single operation and you can change a character. Now if you think logically about it, then from the left, right? So from the very left, if you're gonna change any character, then it would only make sense to make it bigger, right? Because if you're gonna change a character from the very left, then I would always want to make it big. So for example, if I convert this D to a E, it would actually benefit me, right? So if I convert this D to a E, nothing would actually hamper, because then also all these characters that are to my right are actually gonna be having the same values, because the negative aspect of it only depends on the values that are to the right of it. Now since the very first characters are not to the right of anything, hence it would always make sense to increase the values as much as possible, right? On the other hand, would it ever make sense to decrease the value? Yes, it actually would. Let me give you an example. So let's say the string you were having is, let's say they were all maybe like A's. So maybe like there are 1000 A's and followed by a B, right? Now in this case, not even 1000, let's say there are 10 to the power 5 A's followed by a B, right? So in this case, all of these A's were actually contributing a -1 to your final answer. What you could have done is that just by making so there were many A's, maybe like 10 to the power 5 A's. So just by making this B a A, you can now actually, what you can do is that all these A's would actually start contributing a positive value, right? So what we actually learned is that it makes sense, okay, to convert the values from the left side to the bigger values and vice versa, right? So from the right you want to convert to the smaller values, and from the left you want to convert to the bigger values, and that's exactly what we are going to do. Okay, so this is a basic function that gets you the score. So depending on whether if it's a or if it's a B, if it's a C, if it's a D, and if you've already seen B, in case of A, if you've already seen B, C, D, E, then it's a negative, else it's a positive, and I've already explained that. I'm not going to explain that again and again. So I hope you already get this stuff, right? After that, what we're going to do is that we're going to start from the very left first, right? So we are going to mark the locations of A, B, C, D, E. Now for A, if I have a, right? So if its location is not -1, then it would make sense for me to either convert it to a B, C, D, E. I'll convert it and then I'll check the result I'm getting. I'll store that result in a max. Now for B, it would make sense only to make it C, D, E. I'll do that and again store the results. For C, it would make sense only to make its value D, E, right? I'll do that. For D, it would only make sense to make its value E, right? I'll do all of that. And now this was the part wherein we are starting from the left and we are trying to increase the value of it, right? And now we are going to do the opposite, exactly opposite. So we are going to start from the very left. Oh, sorry, we are going to start from the very right and move towards the left. And we're going to try to decrease the value of it, right? So if we are having a E, I'm going to try to decrease it to B, C, A, D. If I'm having a D, I'm going to try to decrease it to B, C, A. If I'm having a C, I'll try to decrease it to A and B. If I'm having a B, I'll try to decrease it to A. And yeah, every time I'll be doing this operation, I'll just get hold of the result I'm getting and I'll keep updating my maximum result, and at the end I'll print it. Now it was just like the code is a bit big because I actually copied the statement, so it didn't take that much time to write it. But yeah, it seems like more of an implementation problem. Again, I could be wrong and there could be much easier ways to code it up, but this is how I did it. So now let's move to the last problem. So let's go over here. The contest ended. Okay, let's move to the last problem. That is pair of segments. So this problem states that you are having two segments. You are having an array of segments, right? Now a segment is always defined by its boundaries, that is L and R. Now you want to make sets out of this segment, out of this entire array, and basically you want to keep k by 2 pairs only, right? Now the quality of this k by 2 pairs, or the property this k by 2 pairs should hold, is that each of these pairs should have some interaction, right? So if I'm talking about any pair A, so there would be two intervals in it, and they should be intersecting, right? So they should be intersecting, and there should be no intersection among different pairs. I hope you have already read the statements. Now the problem was that how we can remove some number of pairs from it, but what is the minimum number of pairs we have to remove? Now this is a standard, I'll say, interval problem, or you can just combine interval along with DFS, and it looks pretty intuitive. I can directly walk you through the code because it's actually simple. If you don't understand it, and then you can definitely ask me in the comment section below, but it's actually pretty simple, right? Okay, so what we're going to do is, firstly we're going to take the input. Now the way I actually take inputs like this is because I've already defined custom input methods, not over here, but actually over here, right? Okay, so I take the array, or this entire array that is given to me. After that I sort it. Now why am I sorting it? Because I want that the intervals who are starting early, right, I want to know about them. Now at every interval I'm gonna make a decision that whether I need to add it to my array or not. That decision I'm gonna make, but I'm gonna start at the very left, right? Because if I'm gonna start at the very left only, or if I'm gonna sort it already and then I'm gonna start looking from the left, then it won't be the case that I'll reach a particular array. So okay, let me just explain that in a brief so that you don't get confused. Okay, so let's say L1 R1 is one of the array, or one of the segment, L2 R2 is the another segment, L3 R3 is the another segment, right? So what I basically want is that L1 should be less than L2 should be less than L3, because I don't want that after this if I reach another array. So let's say after Li, if I reach Lj, right? So on reaching Lj, it should not be the case that Li has its left boundary greater than Lj, because that will actually screw up my logic. So that is not something I want. Hence I'm sorting it over here. Now if you have solved any amount of, or if you have solved even a single question related to intervals, I hope this logic is actually making sense to you, that why do you even want to sort it, right? Now over here I'm saying that okay, it's possible for me to skip the zeroth array or the zeroth interval, right? Or it's possible for me to skip the first interval, so on and so forth. Or it's even possible that I skip the first I intervals, right? So that's exactly what this loop is doing. So this loop basically says that, okay, I'm going to skip, if I'm starting from I, right? So I'm going to start my arrays, or I'm going to start my combination from I itself. So if I'm going to start my combination from I, all the I minus 1 intervals that remain, right, I'll have to subtract that, or I'll have to add that to my answer, because these are the arrays that, or these are the intervals I'm ignoring. So I'm doing I plus 1 over here for that, right? After that, okay, just give me a second. Yeah, looks good. Okay, after that, what I'm going to do is I'm going to go for this DFS call. Now what this DFS is doing is that it has some parameters. Let's try to understand them first. Now I have an index, that is IDX. That's pretty trivial, right? So index is basically at which interval you are currently at, right? Then I have an open pair. Now open pair basically states that, let's say I started, right, and you know that each pair should actually consist of two intervals, right? Now open pair basically means that if I have this pair L1 comma L2, right, L1 comma R1, right? So this was just tell me that, okay, in a particular array, I already have L1 R1 and I need to add another segment to it, right? So for example, every pair needs to have two segments or two intervals. So open pair just defines that what is the first interval that is present over here. So this is open pair, right? Then I have a connect. Now connect is also related to it. If there would be an array over here, or if there would be a single element, single interval in the pair, then this connect would be set to 1, else it would be set to 0, right? Now, why is this important? Now, let's say we already got it, right? So we got a L1 R1 and a L2 R2, and now we want to start a new pair. Now, what would happen is that when we were started, we also need to make sure that this doesn't intersect with this, right? So this should not intersect with this, and hence we need this strategy, or we have calling a connect, because if my connect is set to false, then I'll definitely check that whatever I'm gonna start, let's say I'm putting a L3 R3 over here. Now L3 should not be less than equal to R2, right, or R1. Otherwise they'd intersect and the logic would not be valid. Also, I'm having a DP. Now DP I'm using is 3D DP. You can actually use a 4D DP over here so as to get off this particular logic. And even that would work, because at the end of we are just increasing it by 2 points. So that should work. Now, if I've already stored the value, then I'm going to return it. Else I'm going to say that, okay, this is not required. Let's get rid of that. Okay. Oh, anyway, cool. Let it be, because I'm actually initializing it to the right value. So I know that the resultant at max would be n, right? Or which is the size of the entire intervals, because I can say that I'm going to remove all the intervals, and that's going to be a valid answer for me, right? Else I'm going to say that if I don't want to connect, so basically the previous interval that I actually mentioned over here, right? So the previous interval was already closed. If I don't want to connect, then what I need to do? Then I have two choices. Either I'll keep the current, either I'll skip the current interval, right? If I'm gonna skip it, then 1 would be added because I already skipped the interval. Plus DFS of I'll go to the next interval, right? And the open pair would remain the same. So open pair would basically mean this one, right? And I'll add a 0 for connect because I don't want to connect. And then the values V and DP, and that's basic. Or if I want to add this particular interval, then I'll have to check that its opening should be greater than the closing of the open pair, right? So its opening, that is L3, should be greater than R2, right? So if that's the case, then I can then also I can do it. So over here I'll say that, okay, result is minimum of result, or I'm gonna add it. So a new pair is gonna start. So the next index I'm gonna go to is IDX plus 1, right? I'm gonna go to IDX plus 1, and now the open pair is basically this L3 R3 wala pair, right? So I'm gonna say the open pair is this one, that is IDX itself. I'm gonna say that yes, I want to connect because I actually want another interval with me, so I want to connect, and then I'm gonna pass my B over DP. Else, so this was I don't want to connect. Now this is I want to connect. Now if it wants to connect, then what it will say is that firstly I consider that I'm not adding the current element, right? If I'm not adding the current element, I'm skipping it, so add 1 for it. Plus, so you're gonna go to the next element. The open pair would remain the same. You wanted to connect, that also remains the same, and V and a DP, right? Else you'll have to check that you can only connect this particular element if the current element you're standing at, right, has a L. So over here, let's say, so it should have a L2 that is less than equal to R1, right? So that's what I'm checking over here. If that's the case, then I can connect it, right? And the value would basically be DFS of I'm gonna go to the next one, right? And then now this part is a bit tricky. It's not tricky per se, but you have to understand it, because what could have happened is that let's say you completed your pair, right? Over here you completed your pair L1 R1 and L2 R2. Now R1 or R2, either of them could have been bigger. Now to give an example, it could be the case that your L1 is, okay, so the first pair was like something like 2,8, right? And the next pair was maybe like 4,5, right? Now in this case, although this has a start later on, so it's starting at 4, it's starting at 2, but still its boundary is smaller than this one, right? So the boundary needs to be greater. So over here, I'll have to send an open pair for this. So that's what I'm checking. If its closing is greater than the previous closing, then I'll send this, right? Else I'll have to send open pair itself, right? And now, no, I don't want to connect further. So a 0 for that and a V and a DP. And then I'll return it. Also, when I have reached the very end, so I'll check that if my connect is not set, right? That basically means the previous pair was actually complete. In that case, I'll return a 0. Else I'll return a 1. Now, why am I returning a 1? Because I'll say that, okay, the last pair you constructed, that was basically this, right? So this is what you constructed at the last. You don't need that. So let's say there was one array over here, let's say li ri, or one interval over here. You'll have to delete that particular interval. So you'll add, you'll just return one over here so that one gets added to your final answer. I hope this was also understandable, and if you have any doubts, let me know in the comment section below. Thanks a lot for watching this video. Bye bye.